Hello students, welcome back to Turning Point classes. In this session, I will discuss the first level questions related to the second chapter of second PU physics, that is electrostatic potential and capacitance. Let us start. The first question is two unlike charges are separated by a certain distance. At a point between them, four options are given. We have to check each option. Now let me put two point charges. Unlike charges are given. Say one is a positive charge, the other one is a negative charge. So I will take a positive charge, another one is negative charge. These two are separated by some distance. Let me check the first option. Field can be zero but not potential. So to check the first option, let me take two charges. Take one point. At a point in between them, so take one point. Place a test charge here. Test charge experiences a repulsive force due to this positive charge. This is the direction of electric field. I put it as E plus. Test charge experiences an attractive force due to this negative charge. So this is the direction of E minus. E subscript minus electric field due to negative charge. E plus is electric field due to positive charge. So both are acting in the same direction. So therefore option A cannot be the answer. At this point there is some electric field. So we want at a point between them. Field can be zero, it cannot be zero. So therefore option A will drop. Field can be zero but not potential. Of course if we take here field, so resultant electric field is not equal to zero. I write here E is not equal to 0, but potential can be 0. If you calculate potential here, potential is the sum of the potentials due to positive charge and negative charge. So if you take potential due to positive charge, it is a positive value. If you take the potential at this point due to negative charge, that is negative value. Both have the same magnitudes. So if you add them, so you get potential is equal to 0. So therefore option A is not the answer. That let us check here. Potential can be 0 but not field. So this one fits in option B. So therefore the answer for this question is option B. This is the answer. So rest of the options are wrong. So this is our first question. Let me take the second question. So in the second question we are given the potential at any point inside a charged hollow sphere. Just I discussed in my previous videos. If you have not watched my previous videos, press the I button so you can go back and view the videos, or in my description I have given the other YouTube videos. Go through all those videos that will help you understand the questions what we discuss in the next coming videos. The potential at any point inside a charged hollow sphere, as I discussed, potential on the surface is equal to potential at any point inside. Potential on the surface, it is a charged sphere, there is some potential. Same potential will be there right from center to the surface. It is a constant value. Potential inside a charged hollow sphere is a constant. So therefore, option B is answer for this question. Now let me take the third one. The electric potential at any point xyz in meters is given by V is equal to 3x square. The electric field at a point 2 meter, 0 meter, 1 meter point is given. Four options are given. Such questions have appeared in several CET papers, previous CET papers. Very easy one. So we want to find what is electric field. So electric field E is equal to, in second PUC we have one simple derivation, minus dV by dx, derivative of V, potential difference with respect to distance, minus dV by dx or minus delta V by delta x. So it is a partial differentiation, but I will go for normal differentiation which we learnt in first year and second year mathematics. So this is equal to minus d by dx of V is given, so V is nothing but 3x square. Just differentiate this. This is minus 3. 3 is constant, put it outside. X square differentiation is 2x, in total it is minus 6x. Now we have to put the values given for x, y, z. So x is given as here 2 meters at this point. At this point 2 meter, 0 meter, 1 meter, we are asked to find electric field. So therefore, substitute x coordinate here 2 meter, only x is available, minus 6 into 2. If I do it, I will get minus 12. So this is volt per meter. So minus 12 is in option C. That is the answer for this question. Come back to the next problem. The electric potential due to a charge Q is measured at a distance capital R. The potential at 3 times the above distance due to 9 times the charge will be. 4 options are given. Just recall the formula for electric potential. So electric potential equation is V is equal to 1 by 4 pi epsilon naught Q by R. So Q divided by R. So I have taken Q, R is the distance. Now what is given? Charge is changed to 3 times the above distance due to 9 times the charge. Charge has become 1 by 4 pi epsilon naught as it is. This becomes 9Q. Charge is increased by 9 times. The distance is 3R. Distance is increased by 3 times. Just to simplify, 3 times. So this gives us 3 times same 1 by 4 pi epsilon naught Q by R. So this is available here. So 1 by 4 pi epsilon naught Q by R, I replace it by V. So therefore, the new potential will be thrice the initial potential. So that is the answer. So here we find in option C. Next one, 3 charges 2Q minus Q are placed at the vertices of an equilateral triangle at the circumcenter of a triangle. Now if you take equilateral triangle, circumcenter, of course that is the center of a circle. Let us think this is an equilateral triangle. So from any vertex to this center, the distance is the same. Now just take the given charges 2Q. One is 2Q is given. You can place anywhere you want. Another one is minus Q. This one is minus Q. One more is minus Q here. Now you start finding electric field. First we will check electric field. Afterwards electric potential. So after this diagram, start checking electric field and electric potential due to each charge. And take first say minus Q. At this point, if I place a test charge experiences an attractive force. Test charge is nothing but positive charge. So it experiences an attractive force, that is the direction of electric field. So due to this minus Q, just for my understanding, I put this one as E subscript minus. Test charge placed here experiences a repulsive force due to 2Q charge. Therefore, this is the direction of E plus, charge due to 2Q. That is the direction. Test charge placed here experiences an attractive force due to this negative charge. This is the direction of say minus, that is E minus, this is the direction. So E cannot be 0 because we have 3 vectors. So 3 vectors of different magnitudes. If you find the resultant, so they are all acting in this direction. One is this one. If you find electric field, the resultant electric field, E cannot be 0. Let us check potential. Electric potential at this point due to this charge, 1 more 2Q charge. Electric potential. So V is equal to 1 by 4 pi epsilon naught. First you take the sum of the charges, that is enough. Minus Q is minus 2Q. Minus 2Q plus 2Q simply becomes 0. So electric potential becomes 0 at the circumcenter, but not electric field. That is the answer. We will check. Field is non-zero, but the potential is 0. That is the option B. So answer is available in option B. Coming back to the 6th question. Two conducting spheres of radii R1 and R2 are at the same potential. Ratio of their charges is simple question. Same potential is given. V1 is equal to V2 for the 6th one. V1 is equal to V2. V1 formula is there, 1 by 4 pi epsilon naught Q1 by R1. Right side also 1 by 4 pi epsilon naught Q2 by R2. So I will take straight away Q1 by R1. That is equal to Q2 by R2. So 1 by 4 pi epsilon naught left hand side, right hand side, cancel in the mind. So I want ratio of their charges Q1 by Q2 is equal to R1 by R2. Simple question. R1 by R2, it is there in option C. The next question is two conducting spheres of radii R1 and R2 are equally charged. The ratio of their potential is. So in this question, so we are given the radii R1 and R2 equally charged. Here it is given Q1 is equal to Q2. Q1 is equal to Q2. Now what is the ratio of potential? Just recall the formula. V is equal to 1 by 4 pi epsilon naught Q by R. 1 by 4 pi epsilon naught, I take it as some constant. V is equal to K into Q by R. Q is equal. Now I can write Q proportional to V into R. This is easier. Charge is proportional to potential radius. Q1 is nothing but V1 R1. This is equal to V2 R2. I want the ratio of their potentials. So V1 by V2 is required. V1 by V2 is equal to R2 by R1. So V1 by V2 is equal to R2 by R1. That is there in option D. B is answer for this one. Next question. Two spherical conductors of radii 4 meter and 5 meter are charged to the same potential. Potential is the same. That means V1 is equal to V2. If sigma 1 and sigma 2 are the surface densities of charge, then what is the ratio of sigma 1 by sigma 2? Simple one, this is it. So V potential, just I explained in the previous discussions. So previous videos, V is equal to sigma by epsilon naught times R. That I have given. If you remember that, V is here. V is equal to sigma by epsilon naught R. So I can write V is proportional to sigma into R. So V is equal to 1 by 4 pi epsilon naught Q by R. Little bit of adjustment takes that equation to this format. V is equal to sigma by epsilon naught times distance, that is radius here. So V is proportional to sigma R. I write this one as sigma 1 R1 is equal to sigma 2 R2. I want sigma 1 by sigma 2. Sigma 1 by sigma 2 is R2 by R1. This is equal to R2 I am given 5, R1 is given as 4, 5 by 4. The answer is option A. So with this I end this session. Subscribe to Turning Point classes. Share the video with your friends. Like the video. So I'll come back with a few more questions in the next session. God bless.